Deserts are among the most extreme environments on Earth, characterized by scorching temperatures, minimal water availability, intense sunlight, and nutrient-scarce soils. Survival in such harsh conditions requires extraordinary adaptations, and insects, despite their small size and fragile appearance, are masters of desert survival. Here we delve deeply into 5 remarkable insects that have evolved incredible mechanisms to thrive in these unforgiving landscapes. Desert locust, Schistocerca gregaria. The desert locust is perhaps one of the most famous insects, known for its incredible ability to survive and even flourish under desert conditions. They inhabit deserts across Africa, the Middle East, and parts of Asia. One of their most fascinating adaptations is their capacity for dramatic behavioral and physiological transformations in response to environmental conditions. During periods of drought and food scarcity, desert locusts exist as solitary insects with muted coloring, avoiding predation by blending into their surroundings. When rainfall arrives, sparking vegetation growth, these insects undergo a striking transformation, both physically and behaviorally. They shift from solitary, camouflaged individuals to brightly colored swarming insects that aggregate in massive groups, devouring vegetation in their path. The locust's survival strategy hinges on rapid reproduction and the ability to fly vast distances, up to 150 kilometers per day, to exploit transient food resources, turning harsh desert conditions into opportunities for rapid population growth. Darkling beetle, Tenebrionidae. Darkling beetles are highly adapted desert survivors commonly found in arid regions across the globe, particularly in the Namib and Sahara deserts. These beetles display a unique adaptation critical for desert survival: their ability to harvest water directly from the atmosphere. Their bodies are covered with specialized bumps and grooves that facilitate fog harvesting. During cool desert mornings, when fog briefly covers the desert landscape, these beetles position themselves to face the wind. Moisture from the fog condenses onto their hardened wing cases and is funneled through microscopic channels directly into their mouths, providing essential hydration in an environment otherwise devoid of freestanding water. Additionally, their hard exoskeleton protects them from intense heat and desiccation. Some species burrow beneath the sand during the day to escape extreme temperatures, emerging only at night to feed, further minimizing water loss. Saharan silver ant, Cataglyphus bombacina. The Saharan silver ant is uniquely equipped to withstand the blistering heat of the Sahara Desert, where surface temperatures can reach an astonishing 70 degrees Celsius, 158 degrees Fahrenheit. These ants are active during midday, when other predators are scarce, giving them exclusive access to food sources, like the corpses of other insects that have succumbed to the desert heat. Their most remarkable adaptation is their reflective silver coating, comprised of tiny hairs that reflect sunlight and infrared radiation, allowing them to remain cool despite extreme temperatures. Additionally, these ants have incredibly long legs that elevate their bodies above the searing sand surface, minimizing heat transfer. Furthermore, their movement is astonishingly fast, enabling them to forage quickly and efficiently. Studies have shown that Saharan silver ants are among the fastest ants in the world, capable of running at speeds equivalent to human running speeds of hundreds of kilometers per hour when scaled to body length. Honeypot ant, Myrmecocystus mexicanus. Honeypot ants, native primarily to arid regions of North America and Australia, showcase a unique social adaptation crucial for desert survival. These ants have developed a remarkable method of food and water storage within their colonies, relying on specialized workers known as reptiles. Reptiles serve as living storage vessels, consuming large amounts of nectar or water and storing it in their greatly distended abdomens. These workers remain immobile within underground chambers, providing a reliable supply of nutrients and hydration for the colony during prolonged droughts or periods when external food sources are unavailable. This adaptation allows honeypot ants to maintain colonies in extremely arid regions where surface water and food are scarce for much of the year. Their ability to efficiently manage resources within their colonies exemplifies a sophisticated survival strategy highly adapted to desert ecosystems. Desert cricket, Stenopelmatus fuscus. Desert crickets, commonly known as Jerusalem crickets or potato bugs, are robust insects adapted to life in North American deserts. They are nocturnal, a behavioral adaptation that significantly reduces water loss and exposure to extreme daytime heat. These insects spend daylight hours in deep burrows, emerging at night to forage on decaying organic matter and roots, which provide both nutrients and moisture. Their diet allows them to extract adequate hydration from their food, an essential adaptation since free water is rarely available. Their physical adaptations also play a crucial role. Desert crickets have a thick exoskeleton that minimizes moisture loss and powerful jaws that enable them to feed on tough, fibrous materials found within their harsh habitat. The survival of these insects is not only fascinating, but ecologically vital. They serve as critical links in desert food webs, acting as prey for reptiles, birds, and mammals, while also participating in nutrient cycling and soil aeration through their activities. Understanding their survival strategies provides valuable insights into ecological resilience, adaptation, and potential impacts from environmental changes such as climate change. Insects are often underestimated in their resilience, yet these 5 desert-dwelling species highlight nature's incredible capacity to adapt and thrive under conditions that seem utterly hostile. From ingenious moisture harvesting to efficient heat management and resourceful social behaviors, their adaptations are a testament to evolution's creativity in overcoming environmental challenges. As deserts continue to expand with climate change, these insects provide invaluable insights into adaptation, survival, and the delicate balance of life in Earth's harshest environments.